Hello everyone, this is your junior high school math teacher, and in this video we will continue with the discussion about the 6 trigonometric ratios. And this time we will be taking up the last 2 trigonometric ratios. So in this first slide of presentation, we consider the same set of objectives, and in this module you would be able to investigate, analyze, and solve related problems involving these trigonometric ratios with appropriate and accurate representation. Now, last time I discussed the tangent and the cotangent of an acute angle of a right triangle, and so far you have already learned 4 of the 6 trigonometric ratios. And this time, in this video, we will now take up the last 2. So again, we refer to the same right triangle ABC, and please take note of each of these sides. We know that the longest side is labeled as the hypotenuse, and each leg can be an opposite leg or adjacent leg depending on what acute angle is being referenced. Okay? So the horizontal leg here can be an opposite leg of this angle B, or the same leg can be the adjacent leg of this angle A. Now, going to the other leg, the vertical side of the right triangle, denoted by small letter A, it is also an opposite leg with respect to angle A and an adjacent leg with respect to angle B. Okay? Now, what are the 2 remaining trigonometric ratios? So let us now define those remaining trigonometric ratios with respect to acute angle A. And these are the following. Secant of A, which is defined as the ratio of the hypotenuse to the opposite leg of angle A. And from the right triangle, the hypotenuse is represented by the symbol small letter C. So that is C over the symbol that represents the adjacent leg of angle A, which is B. So the ratio for secant of A is C over B. And the next one, which is the last trigonometric ratio, is actually the cosecant of A. In abbreviation, that is CSC, while the secant is abbreviated as SEC. So again, this trigonometric ratio right here is properly read as cosecant of A. And this is defined as the ratio of the hypotenuse to the opposite leg of angle A. So in symbol, by referring to the figure, hypotenuse is represented as usual by small letter C, while the leg opposite of angle A is represented by symbol small letter A. So cosecant A is equal to C over A. Okay? Now, these are the definition of the secant and cosecant of A or angle A, since we are referring to this angle. And for the other acute angle B, of course, it has its own secant and cosecant trigonometric ratio. Now, for secant of B, we follow the same definition, which is the ratio of the hypotenuse to the adjacent leg of angle B. Mathematically speaking, that is C divided by A. Now, for the cosecant of angle B, angle A rather, no, it's actually B. Wait lang. Okay, so it's cosecant of B, which is defined as the ratio of the hypotenuse to the opposite leg of angle B. So that is actually equal to C over B. Okay? And with that, let us now proceed to some illustrative examples using these definitions of secant and cosecants of both acute angles A and B. Number 1, find the secant and cosecant trigonometric ratios of each acute angle in the given right triangle, where C, which is the symbol for the hypotenuse, has a length of 5, and one leg, denoted by small letter B, has a length of 3. Now for our solution, of course, the right triangle figure here is also given. And this is the figure whose name is right triangle ABC. And from this figure, the two given sides are the hypotenuse, which is 5, and the shorter leg denoted by small letter B, which is 3. So obviously, the other leg, which is the vertical leg denoted by small letter A, has an unknown length. Now, how do we solve for the length of that leg? Basically, we're going to use the Pythagorean theorem here, which states that the sum of the squares of the legs is equal to the square of the hypotenuse. So by setting up the equation, which is the Pythagorean theorem, it becomes 3 squared plus a squared, this one, is equal to 5 squared. And solving for this resulting equation for a, so a here, which is the vertical leg, has a length of 4. And at this point, we can now define the secant and cosecant of both angles A and B. So the trigonometric ratios, or particularly the secant and cosecant of angle A, are the following. Now, secant of A, using the definition, hypotenuse to the adjacent leg, that is equal to 5 over 3. Okay, so this is the hypotenuse 5, and this is the adjacent leg 3. So this is the answer. And for the cosecant of A, it is defined again as the ratio of the hypotenuse to the opposite leg. And what is that hypotenuse? That is again 5, and the leg opposite of angle A has a length of 4. So it's 5 over 4. Okay? And then, how about the secant and the cosecant of angle B? So using the same definition, but in reference to angle B, that is hypotenuse, which is also 5, and the adjacent leg is actually the one having the length of 4. Okay, so this is the angle, so this is the adjacent leg. So it's 5/4 or 5 over 4. And for the cosecant of angle B, that is the ratio of the hypotenuse, which is 5 over the opposite leg, which is the one having a length of 3. So it's 5 over 3. Okay? For our next example, number 2, given theta, which is an angle or acute angle in a right triangle, and sine theta, which is equal to 5 over 13, find the remaining trigonometric ratios, which are actually the secant theta and the cosecant theta. So for our solution, we need to draw a right triangle, and we label those given two sides, and the theta, which is based from this given trigonometric ratio, which is sine. We know that the 13 here is the hypotenuse, while the numerator 5 is the opposite leg to angle theta. Now, where shall we put these lengths from this right triangle? Yun. Okay? So it means this is the hypotenuse, this is the shorter leg, and this is the acute angle theta. And obviously, one side has a missing length, and I denoted that as x. Now, to get the length of the side, of this side, or to get the length of this side, we are going to use the Pythagorean theorem. Okay? Solving for the length of the unknown side denoted by x. Again, this is the Pythagorean theorem. The sum of the squares of the two legs, that is x squared plus 5 squared, is equal to the square of the hypotenuse. So that is 13 squared. Now, solving for x from this resulting equation, we have the following uh, steps of solution. Okay? So x is equal to 12. So basically, from this formed equation, we will transform this in order to solve for x. And step by step, up to the last one, we obtain that the value of x is 12. And with that, all the sides from this triangle are known. And we can now define the secant and cosecant of theta. Yun. And these are, yun, secant theta, which is, we know as the ratio of the hypotenuse over the adjacent leg. So referring to this right triangle, the hypotenuse is 13, and the adjacent leg is the one that we have just obtained for the value of x, and that is 12. Okay? Now for the cosecant theta, that is defined as the ratio of the hypotenuse to the opposite leg. So that is 13 over 5. Okay?